Next we are discussing important points. So what are the important points are there? First point we are writing. First point is what? All such point where dy by dx equal to 0 and function is increasing or decreasing at that point, then that point is called point of inflection. That means concavity of graph will change. So all such point where dy by dx equal to 0 and function is increasing or decreasing at that point, then that point is called point of inflection. And what is point of inflection? Concavity of graph will change. For example, y equal to x cube. So y equal to x cube graph we know. Y equal to x cube graph will be this one. So at x equal to 0, if you see, dy by dx equal to 0. Okay, and if you check here, f of this point, if I take here, this point is what? F of 0 minus h. And if I take here one point, if I take and value, if you find out f of 0 plus h. So you can say that f of 0 minus h is less than f of 0 and f of 0 is less than f of 0 plus h. So you can see that at x equal to 0, function is increasing. Okay, and dy by dx equal to 0, then we can say that here at x equal to 0 is what? Point of inflection. So x equal to 0 at point of inflection, and here concavity will change. So concavity, this is what? Downwards, and this is what? Upwards. Okay, so here concavity are downward to upward is changing, so this point is called point of inflection. Next we are discussing second point. What is second point? If y equal to fx is increasing for x greater than a and x less than a, then at x equal to a, y equal to fx is increasing if at x equal to a function is continuous. If function is discontinuous, then can't say. If function is discontinuous at x equal to a, then we can't say monotonicity at x equal to a directly. Then we have to check. So what is the point? If y equal to fx is increasing for x greater than a and x less than a, then at x equal to a, y equal to fx is increasing if at x equal to a function is continuous. If function is discontinuous at x equal to a, then we can't say monotonicity of at x equal to a directly. Then we have to check only. Okay, example we can take. So one function is this one. So if I take this is x equal to a. So if we take x less than a, increasing, x greater than a, increasing, and function is continuous, so at this point also it is increasing only. So you can check ahead, this is what, x equal to a plus h, and here you are taking x equal to a minus h, and function value if you check, so f of a is what, less than f of a plus h, and this is greater than f of a minus h. Okay, now if function is discontinuous, then what are the possibilities will be there? Sorry, if you check here, function here is what, increasing, and here also increasing, but at a it is, at x equal to, function is discontinuous. So if you check here, that this is what, f of a minus h, and at this point if I take f of a plus h, and this is what, f of a. So what is the condition will come? F of a is what, greater than f of a plus h, and greater than f of a minus h. So we can't say at x equal to a function is increasing, because here it is discontinuous. So in this case function is not increasing at x equal to a. So if a function is discontinuous, then we can't say. If I take one more graph, then this graph we can take at x equal to a, then this value will come and it will come like that. So if you check here, function is increasing here, and here also it is increasing. Now here if you check here, so if I take this one, this is what, f of a minus h, and this one if I take, this is f of a plus h. So if you check here, f of a is less than f of a plus h, and here is what, f of a minus h. So if you say here, f of a minus is what, less than f of a, and f of a is less than f of a plus h, then we can say that at x equal to a, function is increasing, but here function is not increasing. Okay, so function is discontinuous at x equal to a, then we can't say directly, then we have to check this one. Okay, next we are discussing third point. What is third point? If a function fx is decreasing for x less than a and x greater than a, then at x equal to a, function is decreasing if function is continuous. If function is decreasing, if function is discontinuous, then we have to check. We have to check. Same point as second point. In second point we discuss for increasing, in third point we are discussing for decreasing function. So for discontinuous at x equal to a, then we have to check if it is continuous at x equal to a, and for x greater than a and x less than a, function is decreasing, so definitely at x equal to a also function is decreasing. Okay, next, fourth point. So in this point what we are saying, if at x equal to a, f of a, function value f of a is not defined, then at x equal to a, we will not define monotonicity. That means x equal to a we will not include in interval of increasing and interval of decreasing. Okay, so we will not check monotonicity at x equal to a if function value is not defined at x equal to a. This is point number 4. Next is what, point number 5. This is simple. If fx is increasing, then minus of f of x is decreasing. If fx is increasing, then minus f of x should be decreasing. Next point, sixth point. If g of x is decreasing, then minus of g of x is always increasing. Next point, seventh point. If fx is increasing and gx is increasing, then fx plus gx will always be increasing, but fx minus gx can't see. Next is eighth point. Eighth point is what? If fx is decreasing and gx is also decreasing, then fx plus gx will be decreasing function. Next point, ninth point. If fx is increasing and gx is decreasing, then fx plus gx can't see. But in same way, fx minus gx we can say it will be increasing. How we can say? See, fx plus this one we can add minus of gx. So fx is increasing plus minus of gx. So this is what? Increasing. So increasing plus increasing, what will come? Increasing. So we can say that fx minus gx is what? Increasing. Similarly, if I have minus fx plus gx, so what we can see here, this minus fx is what? Decreasing, because fx is what? Increasing. Minus fx will be decreasing, plus g of x is what? Decreasing. So decreasing plus decreasing, what we can say? Decreasing. This is point number 9. Next point is what? 10th point. 10th point is what? If we have fx is increasing and gx is increasing, okay, or fx is increasing and gx is decreasing, okay, or fx is decreasing and gx is increasing, or fx is decreasing and gx is decreasing. Any case will be there. Then hx equal to what? Fx into gx, or hx equal to fx divided by gx. In both cases, we can't say anything about hx, can't say. For example, if I say y equal to x into x, so fx is what? X, and gx is also x. So fx is what? X is what? Increasing, and this is also increasing. But combined function, if we take x square, so y equal to x square is what? This is non-monotonic function. It will be increasing, decreasing both. But this is increasing. So product is what? Non-monotonic. So we can't say if we have product or if we have division. Okay. Next point is what? Point number 11. Point number 11 is what? Very simple. Okay. Fx is suppose increasing and gx is also increasing. Then f of g of x, okay, or g of f of x, both will come what? Increasing function. We can check easily. See, h of x equal to what we can take? F of g of x. Okay, so we are taking two values, x1 and x2, and we can say that x1 is less than x2. Then we have to check h of x1 and h of x2 value we have to check. Okay, so how to find out? So we know g of x is what? Increasing. G of x is increasing. So we know increasing function, if we increase the x value, y value is increased. So g of x is increasing function. So from here we can say that g of x1 is less than g of x2, that we can say. Next is what? F of g of x we want. So f is also increasing function, fx is also increasing function. So you can say that g of x1 is less than g of x2. So we can say that f of g of x1 is less than f of g of x2. This we can say. And what is f of g of x1? You have to put, instead of hx, we have to put, instead of x, we have to put x1. So this is h of x1. And this is what? H of x2. So we can say that if you increase the x value, the h of x value is what? Increasing. So we can say that this function is increasing function. Next point is what? Point number 12. What is 12th point? If fx is decreasing and gx is decreasing, both are decreasing, then f of g of x and g of f of x, this function will become increasing function. How to check? So first we are taking h of x. H of x we are taking f of g of x. So we are taking two values, x1 is less than x2. So first we are finding g of x. So g of x is what? Increasing. G of x is what? Decreasing. So what is decreasing function? If we increase the x value, y value is what? Decreasing. So here we is that g of x1 is less than g of x2. This we can say. Next is what? F. So we know f of x is also decreasing. So we know decreasing function, if we increase the x value, y value is decreasing. So here you can say this is greater than. So here f of g of x1 is less than f of g of x2 will come, because function value will be decreasing. So this is greater the value, so function value will come what? Less will come. So here this is nothing but what? H of x1, and this is nothing but what? H of x2. So we can say that x1 is less than x2 and h of x1 is what? H of less than h of x2. So we can say that this is increasing. Similarly you can check this one also. So this one we can take what? P of x. So P of x what? G of f of x. So here what you are doing? X1 is less than x2. Okay. So fx is what? Decreasing. So we can say that f of x1 is what? Greater than f of x2. And g of x is what? Also decreasing. So what will come? G of f of x1 is less than g of f of x2 will come. So what will come here? P of x1 is less than p of x2. So we can say this is also increasing function, we can say. Next point, 13th point. Fx is increasing and gfx is decreasing. Reverse also we can do. Fx is decreasing and gx is increasing. That also we can do. Or we can say fx is decreasing and g of x is what? Increasing. Okay, both are opposite will be there. Then f of g of x and g of f of x, both will come what? Decreasing will come. Okay, let's check. So suppose we are taking this case. So h of x equal to, we are finding f of g of x we are finding. Okay, this case we are taking. So here x1 is less than x2. Okay, now g of x is what? Decreasing. So g of x is what? Decreasing. So what will come here? G of x1 is greater than g of x2 will come. Now fx is what? Increasing. Fx is increasing. So here f of g of x1 will be greater than f of g of x2 will come. Okay, so what will come here? H of x1 is greater than h of x2. So you can say x1 is less than x2, but function value is what? H of x1 is what? Greater than h of x2. So if we increase the x value, function value is what? Decreasing. H of x value is what? Decreasing. So this one we can say it is decreasing function. So in this case, if fx and gx, one of the function is decreasing and one of the function is increasing, then f of gx will be what? Decreasing will come. Next we are discussing important note. In this note, what we are going to discuss, if in a composite function more than two functions is present, then how to find out whether composite function is increasing or not, that we are discussing here. For example, h of x. Suppose h of x is what? F of g of r of x is there. So here we have three functions. So here first case we are discussing. If in composite function all the functions are increasing, all functions are increasing, then composite function is increasing. So suppose here f, g, r is present. So f is increasing, q, g is increasing, and r is increasing. Then we can say h of x is what? Increasing. That we can say. But in other case we have to check. If all the functions are decreasing, then also we have to check. If all the function is what? Some function is increasing, some function is decreasing, then we have to check. So how? Suppose f is decreasing, q, g is decreasing, and r is also decreasing. Then how to check? x1 is less than x2. Then r of x1 is greater than r of x2 will come, because r of x is what? Decreasing. Next is what? G of r of x1 is less than g of r of x2, because g of x is what? Decreasing. And f is also decreasing. Then what will come? F of g of r of x1 is greater than f of g of r of x2. So this is nothing but h of x1 is greater than h of x2. So you can see here h of x is what? Decreasing. So you can see f is decreasing, g is decreasing, r is decreasing. So this is decreasing coming. Suppose we have four functions, okay? Hx equal to what? F O G O R O Q of x is there. Four functions are there, and f is decreasing, g is decreasing, r is decreasing, q is decreasing. If four functions are there and all are decreasing, so we can say that h of x is what? Increasing. So we can say that if all functions in a composite function, all functions are decreasing. So if in that function odd number of functions are there, then that composite function is what? Decreasing. If even number of functions are present, then we can say that composite function is what? Increasing. For example, this one we can say. So in this function, three functions are present and f, g, r all are decreasing. Then you can say h of x is what? Decreasing coming. But if you say this function here, f, g, r and q is present and all functions are decreasing, then h of x is what? Increasing is coming. But if in a composite function some are increasing, some are decreasing, then we have to check like that. Okay.